No, 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 no. Mic check, mic check. All right, let's keep. Do, 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 do.
Say that you're doing something wrong because you didn't code the way they do, you didn't lay it out in a certain style, you haven't indented it this way or that way, and that you should just give up and walk away because you don't know what you're doing. That is absolutely wrong because there's no wrong way to do this. If you write code that accomplishes what you need to get done and it runs, fine. Now, that is not to say that there might be an easier way to do it, and kind people in the community that see what you've done may come along and offer some constructive criticism and say you could do this way, and that's perfectly all right. Just kind of ignore the negative people because they're really non-productive and they don't help anybody, and they're not going to help you either. And if you are moving along here and advancing, keep in mind that we all have to start somewhere. So once you learn more about this, remember that there's always somebody coming up behind you who's just starting out. And it's my little soapbox for the video here, so we can get into the basic stuff. So in order to write a basic script, you will need a text editor. All distributions of Linux ship with a text editor in the menu. If you're running Ubuntu with the Noob desktop, it's gedit. If you're running Linux Mint, then you get xed. If you're running other distributions, you may get something called Kate, or you might get something called Mousepad. Whatever it is, it's a plain text editor, and they all do kind of the same thing. They allow you to type plain text in and save them. There's also a bunch that run in the terminal. There's Vi or VI, depending on how you want to say that, which is the most basic editor of all. It's very hard to use for people just starting out. It tends to be a little bit cryptic. My favorite to use in the terminal is Nano, and we're going to be using Nano today. So yeah, I'm not a Vi fan out there, guys. Sorry about that. So let's talk about writing a very basic script. And all you really need to know is just these three things. First of all, it has to start out with a shebang or a hash bang. And what that does, it tells the system that this is going to be a script, and it tells it where to get its command line interpreter to run the script. And in most cases, that's going to be bash. You may see some scripts out there that point to sh, and that is the original shell. These days is like a compatibility layer. That's what I was trying to say. Yeah. sh is the original Unix shell, and Linux, being a Unix-like system, will run sh. Sh is for portability. It will run on any Unix Linux system out there. But you don't need to write in sh if you're doing it for Linux. Pretty much every system has bash on it. And we'll talk in later videos about writing portable scripts that run on all kinds of systems. We're concentrating on writing scripts that are going to run on your own system for the video today. Linux being a Unix-like system, let us jump into a terminal, and I will actually show you this stuff instead of just looking at text, and we'll get right in. So with Nano, you can just type in Nano and then hit enter, and then choose a file name to save your file as later, or you can give it a file name right up front. We're going to give it the file name first, and I'm going to use the .sh extension. You don't have to do that. The main thing about naming your script is that your script will have a unique name. You don't want to name your script after something that is already a command on your computer. So you can use the which command to see if something is like what you want to name it. You want to keep it simple, of course, because you're probably going to have to type it again and again. And I put the sh extension on scripts that aren't going to be permanently installed in a place on the computer where they become like commands. Maybe it's a script I want to keep over here that I'm going to run occasionally. That way, if that script ever gets separated from its friends in its little directory that it's living in, I know that, oh, this is a script. And a lot of times the desktop will identify anything with an sh as a script as well, or at least it should. But you don't have to use that extension. So now let's open this up, And the first thing that we need to put in our script, as we discussed, is the shebang, which is basically a hash mark, pound sign, whatever you crosshatch, whatever you want to call that thing. And then we put an exclamation point. And then we put the path to where our interpreter is. In this case, it is bash. So it's bin bash. You're going to see scripts out there that point to other things like sh. We talked about that. We can also have, this is the same format that scripts that run in Python use. It just points at Python. So if you want to learn other languages, there you go. They kind of work the same way. So once you have that in there, you can now put a comment in your script, and I highly recommend that you use lots of comments in your scripts. We are going to write a script today and yes, I am going to commit horrible typos, all kinds of typing sin as we do this, because that's just the nature of how my brain works. I can't type and talk at the same time, so there will be plenty of opportunities for you to point at the screen and laugh. But you get the gist. So you want to put up front a comment that basically kind of tells you what your script is. Anything that starts out with that little pound sign there, other than your shebang, will be regarded as a comment, and the system will not try and execute anything you put in there. So now you can start putting in commands. Of course, you could just put commands in. You don't have to put comments in if you don't want to, but it's a really good idea to do that and make them detailed so you understand what they're doing. And the reason why is because if you write your script today and go back and edit it tomorrow, you probably are going to be able to figure out what you did. But if you write a script and come back 6 months, a year, or a couple of years down the road, you may not know what you were thinking at the time and why you put what you put in there. So you really need to notate that well. That happened to me just the other day. I was looking at a script that I wrote a long time ago, and there was this one command in there, and I was thinking, I don't need that. And I hadn't put the note in the script, this needs to be there. I took it out, then my script stopped working, and I went, oh, I guess I need that. And I went back and did it, and that was my fault because I didn't document it. So let's go ahead and write our command. We're just going to put a simple echo command. All the echo command does is it prints on the screen whatever you put in here.
JP Morgan Chase invests in infrastructure.
In quotations, and you notice that as we go along here, this is changing colors. That is something that a lot of good text editors do to make it easier for you to interpret what you're looking at. That's it. We've written a script. One thing I would like to point out is that as far as comments are concerned, you can also put them after a command. And sometimes this is really useful when you have a bunch of little short commands and it's very dense, if they're clustered and they're indented in certain ways, so you can see exactly what that command is doing. Stuff that's really kind of intense and not very obvious looking, you can do this and it makes it a whole lot easier down the road. So we can put a command, we can put a comment after this that says what this does. Prints stuff on the screen. You know, that's all you got to do is put that in there like that. It's optional, but it's nice to have. So, that is our basic script, and all we have to do now is save it. So in Nano, it's Control-O to save. We already have our file name there, and we have saved our script. We get out of Nano, and let's make sure that it's there. It should be. So go in, we'll list the storage, and we'll do it the long way so we can see it. What? See, I told you, man. Lots of opportunities for laughter here. So there's our script in here. You see the one thing. Now, this isn't executable yet. It's not going to run. We have to make it executable so it will run. And we can do that one of two ways. We use the change mode command, CHMOD. Just don't put the E on the end. Now we can make it executable by adding +X to it, and then give it the file name, which is called first. And this should make it executable. Now, how are we going to know that? I'm going to list it again. And look, it has changed color now. The shell that we're working in, Bash uses color codes on the screen as well, if your system is set up to do that. And if it's an executable file, it shows it in a different color there. So we know that that works. There's another way to do that, and it's actually my preferred method for making things executable because I have more control over it, and that is to use Octal, where you give the permissions directly. So with Octal, I'm not going to get too deep into this, but Octal is it's just numbers. So the first set of permissions here is for you. The next set of permissions is for people in your group, and the last set is for people in the world, anybody that can see the script. So you can make it executable or not executable by adding the right numbers, and it's really quite simple. If you have a 4, that means it's a readable file. And then if you add 2 to that, so number 2, that stands for a writable file. So if you want something to be readable and writable, then you put 6. If you want it to be executable, then you just add a 1 to that. So execution is a 1. So I can make this so that, for instance, right now it is, I can read, write, and execute it. People in my group can read it and they can execute it, and people who come across the script from somewhere else, they can execute it and they can read it as well. But I can change that. I can put like this and say, okay, so now I'm making it so you can read it, but you can't execute it. I'm the only person that can execute that script. So let's go ahead and put that in there. And then if we list it again, now you will see that the only thing that you can do over here in these permissions that are listed at the first part there is read if you are not somebody. Anyway, so you get the main idea. If that was confusing to you, then just remember the first command, which is just add executable. And if we do that and we list the storage again, look, that's what we get.
Hey guys, Dan here from Weather Zone 411. Today what I wanted to do is
So everybody can execute it. Okay, so now that it's an executable script, we need to test our script, and the best way to do that is just run it. The script is not yet in a place where the system will automatically find it. Let me clear this and do that this way so you guys can see what I'm talking about. So what you're going to have to do is tell the system where it is. There's 2 ways to do that. You can do an absolute path to the script, which means that you tell it how to get there. So in this case, it would be home, and then it would be my name, Joe, and then it would be junk, and then it would be the script first, and it'll run. Let's see if it runs. Well, it ran. It printed hello world. We know that works. But that can be a bit cumbersome. So there's another way to do that. And that is just simply to start out with. And what that tells the shell is, okay, it's right here. You don't have to go looking for it. Don't look in the path. Don't look from any of that garbage. Don't do it. It's not there yet. We haven't stuck it there. So just run it from here. So we know our script works. So if you've written that script with me and you're running it, congratulations. You have run your very first script. So what we want to do now is we want to talk a little bit about how to test the script. And I have here all that stuff. And basically you just run it. And if you run into errors, then what's going to happen is that it's going to tell you what they are. But sometimes it gets a little bit confusing, and you'd like to see what the script is actually doing, because most commands don't automatically just print what they're doing out to the screen unless there's some sort of output coming out of them. And sometimes you just don't know what's going on. So to fix that, what you can do is you can run, I don't know if this is going to do much for us. Let me get back over here to nano first sh, right? So all you do is you want to put tracing on your script. You put this option on bash there. And then go ahead and save your script. I don't know how much we're going to see because this is such a simple script, but we'll give it a try. We'll give it a try. We'll see what it does. Okay, yes. See how it is actually showing us? It says plus and then echo world. It's telling us what command is running, and then it shows us the output. This can be very, very useful. Now, once you've figured out what's wrong and you have fixed your script and it's running the way it should, then go back into your script and then remove that right there and save it. And now when it runs, you're not going to see that. You don't want to leave that in there for, your script to run all the time. You really want that to be right there. So that's it. You have written a script. So now the next thing is where to put it on your system to make it useful. So let's go look up here at our documentation about this, and we'll talk about this, because there's a couple of places that you can put it. Okay, the first place that you might want to put it is your own bin directory. If you're going to be creating scripts, compiling programs, whatever, you might want to have your own private bin, and you would do that simply by creating a directory called bin in your home directory. So let's go to my home directory and let's list it, and you see that I have created a directory in there, lowercase bin. Now what happens is the configuration files for bash, when you load up your system, they are looking for that particular little directory, and if it finds it, it will add it to your path statement. So let's take a minute here and talk about your path and what that is. And we're kind of getting ahead of ourselves because we're talking about variables, which we're going to get into more in a future video. But a variable is simply some bit of information that is stored in memory for the shell to use. And you can create your own variables. We'll talk about that later, but now we're going to talk about a shell variable called path. To see what that looks like, we just execute this command, path in uppercase. And you see we've got this long thing here. Well, what this is where your programs live on your system. And you notice that the very first thing in my path is /home/joe/bin. That is because I created that little directory called bin, and the system looks for that.
Imagine being able to build an app with your name on it, just by thinking about it. Meet Base 44.
And actually, I will show you where it looks for that. So if we are going to, I just want to cat.bashrc, and the cat command just types it on the screen. This is the one of the configuration files for when you boot into your system and the bash shell loads. It looks at this to look for certain parameters. Most distributions have one. And you have all kinds of different things in here. So let's see if it's in here, or it might be in profile. Actually, I do think it's in profile. So let me go down here. We'll do that to profile instead. We're going to get back to bash RC in a minute. Profile is another one. So the profile one is actually really short. This is a configuration file that when the shell loads, it grabs a bunch of stuff and it puts it in here. And let's see. It's a lot of the stuff that you see in your bash RC file might be in here as well. It's okay if it's duplicated. And so anyway, in the profile, you'll see this bit of text right here, this command. What this does is it searches for your bin directory that you've created, and if it's there, it adds it to the path. That's how it works. So I went through all of that to show you that, and this is where it is. Now, I have noticed in some distributions that for some reason or the other, they have done something. Usually what this does, the profile, is it grabs your bash RC if it exists, and then it runs it. And then your bash RC runs, and it dumps back out of that, and then it's supposed to run this. A couple of distributions like MX Linux, for instance, for some reason or other, when it runs the bash RC, it doesn't catch this. So what you have to do is grab this little bit of code here and stick it at the end of your bash RC so that it will automatically find the bin. But in Ubuntu, Linux Mint, and many others, it just finds it, and there's no problem at all. Now, what I have done here is I have made it so that if you do need to add that to your bash RC, I've made it a little bit easier, because what I have done is I have come up with the same kind of code in a little bit simpler way. So if your system isn't finding it for some reason, stick this at the end of your bash RC, or create a .bashrc file in your text editor and just throw this bit of code in there. And what that will do is it will cause that to do exactly the same thing, and it's just written in a slightly different syntax. So yes, that kind of puts us ahead of where we are in this, but there you go. So that's the first place that you can put stuff, and I highly recommend having a bin of your own to put your own programs in. The other place to put stuff like this is user local bin. This will make your script available to not only you, but everybody else on the system. And if your script at some place requires elevated privileges, then you want to maybe put it there, because then you can run it with sudo in front of it, depending on how the script is written. Anything that runs in your own local bin directory is not going to be able to be executed with elevated privileges. It's just because when you type sudo, basically you're trying to run a program as the root user, and the root user is not going to be looking in your personal home directory to find the information, where it doesn't have the same path. It doesn't have the same information in the path as far as where it looks for its programs. So now that we got through that, and I certainly hope that I didn't confuse you, let's talk about a few things before we wrap this up. Bash is very well documented. Don't hesitate to search the web for help. When you're trying to do something, if you say, how to blank in a bash script, you would be amazed at what comes up. I've written entire programs that way. I mean, I had no clue what I was doing, but I knew what I wanted to accomplish. So I phrased that in such a way, and I put it in Google, and I typed it, and boom, I got 14 different explanations of how to do it, and I just picked the one that looked the simplest and easiest for me, and sometimes it's just a matter of copying, pasting code in your script and making it run. That's it. It's pretty awesome. Very important that you always use an absolute path when calling on a file in a script. That is a big deal. So in other words, if you're going to be writing to or grabbing a file, then you'll want to use an absolute...
All right, I think that's the end pretty much the end of the video there. Again, that was Joe Collins' channel on YouTube. The name of the video is Linux Bash Shell Script Basic Part 1. I'm gonna go watch his part 2. I think he's got it on here. Yeah, he's got a part 2 a little bit later. But I just wanted to look at this really quick. I found some documentation, the Bash reference manual from the GNU project. I just want to check this out really quick. What is Bash? Bash is the shell or command language interpreter for the GNU operating system. The name is an acronym for Born Again Shell, a pun on Stephen Bourne, the author and director of the direct ancestor of the current Unix shell, SH, which appeared in the 7th edition Bell Labs research version of Unix. Bash is largely compatible with SH and incorporates useful features from the Korn shell, KSH, and the C shell, CSH. It is intended to be... I don't know what the IEEE standard 103-1 is. I don't know what that is. And yeah, I'm not sure. It offers functional improvements over SH for both interactive and programming use. While the GNU operating system, I don't know why they're calling it the GNU operating system. Anyhow, like other GNU software, Bash is quite portable. It currently runs on nearly every version of Unix and other operating systems. Independently supported ports exist for Windows and other platforms. I know they had it on, I thought it was Mac OS. Could have sworn it was on there, but what is a shell? At its base, a shell is simply a microprocessor that executes commands. The term macroprocessor means functionality, where text and symbols are expanded to create large expressions. A Unix shell is both a command, interpreter, and programming language. As a command interpreter, the shell provides the user interface to the rich set of GNU utilities. The programming language features allow these utilities to be combined. Users can create file-containing commands, and these become commands themselves. These new commands have the same status as system commands in directories such as /bit, allowing users or groups to establish custom environments to automate their common tasks. Shells may be used interactively or non-interactively. In interactive mode, they accept input types from the keyboard. When executing non-interactively, shell executes commands read from the file or a string. I better save this. Hold on one second. Let me save this to... let's see. There's a save button here somewhere. I'm pretty sure I can save this PDF. It's free, so I think that's it right there. Yeah, save it, and I'll just save this in documents and call it Bash. All this stuff is free at GNU or GNU.org. If anybody wants to read this documentation. Let me scroll down a little bit here. These definitions are used throughout the remainder of the manual. Post-IX, a family of open standard system standards based on Unix. Bash is primarily concerned with the shell and utility portions of POS IX 103.1 standard. Blank a space or tab character. White space, a character belonging to the space character class in the current local for... Man, when was this written? Holy cow. Let's see here. And it's pretty much review there. Okay, so this is what the gentleman was saying in his video. When the shell reads an input, it proceeds through the sequence of operations. If the input indicates the beginning of a comment, the shell ignores the comment symbol. I don't want to call it, it's hash, I guess, and the rest of that line. Otherwise, roughly speaking, the shell reads its input and divides the input into words and operators, employing the quoting rules to select which meaning to assign various words and characters. The shell then parses these tokens into commands and other constructs, removes the special meaning of certain words or characters, expands others, redirects inputs and outputs as needed, executes the specified command, waits for the command's exit status, and makes that exit status available for further inspection or processing. Shell operation, quoting, escape character. The non-quoted backslash is the bash escape character. It preserves the literal value of the next character that follows. Okay, removing any special meaning it has, with the exception of new line. If a new line pair appears and the backslash itself is not quoted, the new line is treated as the line continuation. That is, it removed the input stream and effectively ignored. Okay, let's see here. I'm gonna skip through here a little bit just to see what else. This isn't the PDF that I was actually looking for. There was another PDF that I read online a few weeks ago. Okay, yeah, this isn't at all what I was looking for. I mean, it's kind of what I was looking for, but I want to go back. I found a... Let's go back here. There was another one. It wasn't put out by the GNU project. It was put out by another free resource. It was like a university, something like that. It wasn't WordPress. Was it this one? Wait a minute, is this the same exact thing? I don't think that's the one that I was looking for, but I'm going to save that one just so I can access it offline. Go ahead and save that one. What the heck? Let's go back a step here. I don't think this is it either. Let me look at the table of contents. Input, output, throughput, looping and branching, command line parsing, and expansion. Parameters and variables, shell functions, string manipulation, file operation command, reserved words and bulletin commands, writing bug-free scripts and debugging the rest, programming from the command line, runtime configuration, data processing. That's not it either. But let's go back here. UT San Antonio. Wait a minute. Let me see if that was it. That's... I have that book, I think, somewhere. That was given to me a long time ago. Let me see something here. I wasn't using Linux then, obviously. I just kind of, somebody gave it to me and I just stashed it. I didn't even know what Linux was. Let me check my phone. I know it's in my browser history. Let me see something here. Let's see what that was. Nope, it's not there. I can't remember where I was reading this. I'm gonna go check out that San Antonio UT. Let's see if that was the one. This kind of looks like it, but it's not. Does it have a table of contents? This is a slideshow. That's not what I was looking for. Here's a website. Command line Kung Fu. Let's see what this is about. Command line Kung Fu by Jason Cannon. Let's see. Shell history, text processing and manipulation, networking and SSH. Send emails from the command line. Say what? You can do that. Send email attachments from the command line. Create an SSH tunnel to. Oh, this might be fun to read. I gotta check this out. Shell scripting used for a loop in command line. Command substitution. Store command line output as a variable to use later. Under system administration, there's a thing there called display mounted file systems. Kill a process for a given user or program. Let me see. Bear with me, this is bugging me. It's driving me crazy. Okay. I gotta move this over. There we go. It was taking up too much of the screen. Move this over here. Wait a minute. Hold on. What is this all about? Display current date and time in a different time zone. The TZ environment variable specifies the time zone. If you want to know the time in a given time zone, let's see. I'm curious. Okay, so $, what did they say? TZ equals, let's put in EST. TZ EST. Oh, maybe you have to write this. The TZ environment variable specifies the time zone. If you want to know the time zone, Is a common practice to use UTC as a time zone on servers. If your workstation or laptop is in a different time zone, you can create an alias that quickly gives you the UTC. Oh, I see what they're doing. Okay, so $ UTC. Let me try something here. I'm gonna experiment. It's the only way to learn, right? Let's go $alias UTC equals. Oh gosh darn it. Come on. How did I mess this up? Cancel. There we go. UTC TZ equals UTC date. Okay, let's see if I typed that right. Okay. And let's just name this UTC. All right, let's go to ls. Okay, it's saved it, but to make it executable, we have to do what? We have to do -x UTC. Oh, damn it. How did we do that again? Oh, I know why. I think because maybe okay. Okay. Yeah, it didn't do it either. It should be in my history here. Oh, wait. I think I might have figured it out. Hold on. There we go. Okay. Okay, now ls. And then see. Oh, damn you. I forgot to put the sh. It still didn't work. What am I doing wrong here? What am I doing wrong? Probably because I didn't write the code right, but let's see. ls. Okay, it's executable. Okay, it's definitely executable. So I didn't write it right apparently. Let's go back to nano utc.sh. UTC equals TZ equals UTC date $. So apparently that's not it. Equals, I wrote it correctly, but apparently there's more to it. Let's here, let me ask Google really quick. See, they're doing theirs like all. Here, let me copy that really quick. I hate doing this, but we're gonna try it. Nano utc.sh, and let's copy all this. Delete. So if we type using date command, I don't want to use date. Let's see. I just want to use UTC. UTC time maybe. UTC time equals date. So to get that, you have to type how it works. Forces the output of the UTC instead of local time. Date U. All right, let's save it. Just for the heck of it and see what happens. Okay. Okay. Date. No shit, it worked. So instead of having to do, okay, so if we go there, wait a minute. Now I'm really curious. Can I do this from the home? It still worked. Interesting. Okay, I didn't know you could do that. Let me see if I go to another directory. Let's say I was in downloads. Could I type that? Or was that already in my thing? Now I'm kind of curious. Now I'm curious. Oh, this is a bad thing when I get curious. Damn it. Okay. utc.sh. Okay, it won't work because I'm in the wrong directory. So we'll change the directory to, what is it in? Documents, or is it in bin? Okay. It's not executable. That's why. Okay, so we need to type cmod, cdmod. Oh, what is it? Cmod, chmod plus utcs. Okay, ls. Oh, there's a space in there. utc.sh. Interesting. Let me delete that really quick. Let's go ls and then rm utc.sh. Okay, ls. We're going to write this again. And okay, so it's not there, it shouldn't run. So let's go back and then oh, see, it already does it. There's another, it's already in there. It's already in there in another thing, so I didn't really do jack. Hold on. Oh man, that's really disappointing. Darn. Darn. So it's already something in my system that allows me to do it. So what if I were to do date E? No. Date M? What about man date? Okay, let's see here. Printer set system date and time. Okay, D does that debug. F file date. Resolution R UTC. That's why it's already doing it. So I didn't need to even write a script for that, but let's try to find something else. Version. version, date, copyright 2023 Free Software Foundation Incorporated. This is free software. You are free to change change and redistribute it. There's no warranty to the extended permit by law. Written by David McKenzie. Date. Two, 3, 4, 5, 6, 7. Okay. 6 hours. Jeepers creepers. I wish I would have known that years ago. Bummer. All right, let me move that up here. So let me see something. I don't like using this fake AI stuff, but let me try something. What can we test out? Right, a let me just go into Nano real quick and just see what this says. It's not really what I was looking for. Let's go back to gosh darn it. Persons we might want $40. All right. Well, that's not exactly what I was looking for. Let me go do some more digging around the interwebs here and see if I can find what I was looking for. And then I shall be back. All right, guys, have a good day. I'll see you in a few hours.